Alright, I think I am ready to go. And I will be talking to myself for a little bit here. But this is my first stream. It's going to be a Rust stream, and let me see if I have everything set up properly, and I'll start discussing what we're going to be working on today. Yeah, no one in chat so far, um, which makes sense. Let's see. I got my chat there. All right. I'm just going to go ahead and make a directory for descriptions, and then I'm going to open up a descriptions stream one. Boy, I can't type. Empty. We're going to talk about some resources for today's stream. I'm going to be talking about Atari 2600 emulator development. And during the course of this and the next few streams, I will be. Music is distracting to me. 1 second while I turn that down. Yeah, so we're going to be talking about developing an emulator from scratch. I actually have just the world's tiniest amount of emulator building experience. I built the first part of a Chip 8 emulator. There will be some interesting problems. Uh, there will be some interesting problems coming up. Specifically, I stopped the Chip 8 emulator when I got to timing. I don't know exactly how I'm going to tackle timing, but that is the goal is to actually have a fully functional emulator. I wanted to walk through a couple things. I'm going to share some Google Chrome on screen. See if I can find that window. All right. The first thing is why I'm doing this. Years and years ago, I decided to learn how to program old console games. I grew up playing Nintendo and Super Nintendo, and have always just really enjoyed the games on those. Went to go research Super Nintendo and Nintendo development, and they're pretty tough. Um, but I did find a thriving community of people programming for the Atari 2600, and I built a unbeatable tic-tac-toe game. My job at the time, um, that was the sort of code test we would give people. Um, what am I trying to think? And so I decided that I would implement it in Atari 2600 tic-tac-toe. So I'm gonna be using this as a test of my emulator as we go along, and I'm going to be um, I'm going to link that in the resources and in the chat. I'm on a different computer and with a different keyboard than I have normally am, so I will be fumbling through some stuff. But so this is tic tac toe in Atari 2600. Let me not use that one. Shift V. Okay. And then in the chat, if you want to see that. And then we'll talk about a little bit. I'm not going to go super into architecture up front. We'll just start emulating stuff. Let me see if I can find my window again. All right. This is a programmer's guide written in not now, written in 1979, which talks about the entirety of the architecture of the Atari 2600. Some interesting things to note here is there's something called the TIA, which was the sort of which is the controller for the like TV interface. I think it's television interface adapter. Um, and while it sounds like they're like it might give you an abstraction to the TV is like is not very well abstracted. You actually have to um, you have to take into account how long scan lines take to get to the end of the page and back. And there's some stuff. Maybe there's some pictures in here about like overscan and stuff like that. Yeah. So you can see that this has clock counts. Basically, you have to keep track of how long your instructions take to execute, and basically the goal is to get all of your game logic to happen when you're not drawing, because you have to basically set up a couple of buffers before a line draws, and if you want something to draw on the next line, you have to like set those buffers up. There's a lot of like strange tricks that happen because of that. So you're going to be doing a lot of like you'll see. Actually, I can show you. Let's see. In my source, I probably have some. Not here, but in some other. Oh yeah, here we go. Here's me like counting out clock cycles for different instructions, stuff like that. I will. This has everything you need to know to program for the Atari 2600 included. So I will again copy that. Control C. Not there. This is Stella Programmer's Guide. Shift V. There we go. Put that in chat too. For all of you. And let's see if there's anything else. Oh yeah, this is a nice page that talks about the 6502, which is the main processor in the Atari 2600, and the important thing here is that it has all the length of the timing. It talks about like adding cycles if you cross page. Mostly it's if you cross page boundaries. Sometimes it's for branch instructions. The branch taken. If you take a branch, it takes longer and things like that. I'll go ahead and post that too. Let's see, 6502 instructions. Okay, there we go. And we'll just write that. And paste it here. All right. So we're going to be writing this in the Rust language. I'm a little bit shaky on Rust. It's been a while. The last thing I built was a chat bot for posting PR requests to Slack from GitHub. It will. Yeah, so it'll take me a little bit to get up to speed, but that shouldn't be a problem. Let's see. So we're in streams, and so we're just gonna cargo init. We're gonna call this Stanley. It's a streetcar named Desire reference, and we're gonna cd into Stanley. and open up our project. Alright, so I should have all of my LSP stuff set up. We'll go ahead and add all this stuff. Boy. I switched to this keyboard recently for to help me with some RSI issues, and I wasn't that fast or great a typist in the first place. And it's been a couple weeks, and it's still causing me a lot of problems, especially if I just revert to my old habits. I end up just like on the entirely wrong keys and hitting just random buttons, which is what you just saw. So I'm going to add -P. Cool. We want to ignore target. We'll add that. Oh, I say I still have Chrome on top. Thanks, chat, for letting me know. All right, so I'm just adding everything to the repo for now, and we'll just do a cargo run, make sure everything's set up properly and working. All right, there's Stanley. All right, so it's running Hello World. First thing I need to do, actually, I'll bring Chrome back. Is download the binary from my repo here. What am I looking at here? It's wild. Oh, this is a different thing than I was. Sorry, the binary is in dist, not in that random. There it is. So well. That's a weird thing about being on Windows subsystem for Linux is that I don't know exactly how to. I think it's like mount C download. No. Users, downloads, and then what is that? Oh man, I got a lot of stuff here I shouldn't be showing. I'm gonna turn off Chrome real quick. Okay, oh, I'm gonna turn off the terminal. Okay, this is going super well. I didn't expect my first stream to be good, so if you're watching back with me, I'm just getting the hang of this. If you're my one viewer, which I think might be me, then please bear with me while I figure this out. Okay. Let's see. Users, Joe. And then that's called tick, tick, tack, toe, nope, downloads. And we'll move that to here. Okay, I think I'm good to turn everything back on again. I won't need Chrome for a little while, although I will turn it on and show you that I am going to go to the Rust docs and just have those suckers open. Rust docs. There we are. Because I will need them as we work through this stuff, but I'm going to try my best to give it a shot first and then see if I can figure out what's going on. So today the goal is to, let me turn Chrome off. Need to remember how to do that. And so actually the first thing we'll do is cat. I need to remember to keep talking because this is going to go on YouTube. All right, so I made that initial commit, and I'm going to push it to GitHub. Again, give me a second while I go over to my Chrome. I'll turn that on. All right, we'll go to new repo. We're going to call it Stanley. Very rusty Atarii 2600 emulator. The public file, we don't need the readme and git ignore, that's all done. Let's choose a license. That will be, we'll just do MIT, use it as you will, modify all that stuff. Make money off of it. I'm sure that it will be really lucrative. And then we'll switch back over to our terminal and do git remote add did not do that right. What does GitHub call? It's main branch now. I think it's just main, right? Nope. Origin. Man, I haven't had to do this in a while. I did not do that right. Let's see. I think GitHub might have some information for me. Okay. 2 equals origin main, and then we'll do main. Okay. Pretty soon we'll beat the creating a repo boss. Hold on, I'll turn this off. All right. So that was fun. I didn't have the passkey memorized here locally. It's a different machine than I'm used to, but I think I should be able to fetch. Apparently, I'm going to have to do it every time. I'm going to work locally for now then. All right. Let's get started. So, basically, the way that we're going to develop this, I'm going to try and do tests where I think they are necessary, but I think our main test file is going to be this tic-tac-toe bin. Let's see. Let's see what this says about that tic-tac-toe. I think that's fine. It's executable. Doesn't really matter. That's interesting though. The permissions are like that. All right. So then we're gonna go. Open Vim, and we're gonna go to main.rs. And so to pull in a file, we're gonna have to read a file as binary, and I'm gonna have to remember how to do that in Rust. Actually, let's see if I can explore how to do that here, one step at a time. So, use standard FS, right? Passes an operation. A module contains basic methods to manipulate the contents of the local platform. Cool. So we're gonna do that, and then I believe that FS has read. Let's see. Let's make sure that I know what I'm looking at. Read the entire contents of the file to a bytes vector. Fortunately enough, we are working with bytes. That is probably exactly what I need. It's going to give me a result with an error. We might do some real error handling a little bit later, but for now we're just going to probably use strings and unwraps and stuff like that. So actually, in fact, I'm just going to... We can do this in Rust, right? We can do result. Yeah, actually, let's not do that. Let's just do an unwrap for now. We will figure that out. Unwrap. Cool. And so I'm going to write a little command here. I'm going to map my comma t to write the file, and then cargo run cr. So this means every time I hit comma t, it'll run my project. So we'll see what we get when we run it. All right, so expected one argument, got none, which is exactly right. Okay, so we've successfully read that file. Let's see if we can inspect the first byte of it. The bytes are going to tell us how to, what instructions to run when we get to our emulator. So the basic idea of an emulator is that you read the code into memory, and then it's a series of bytes. The 6502 has variable width instructions, so we'll have to decide how much of the code, or how many of the code bytes to consume each time, but then we'll move on to do something, move on to the next, jump around, that kind of fun stuff. All of that will be fun challenges to do, but for now, why don't we see if we can just find the first one. So we have a bytes array. So let bytes equal. So then we should have. Is it a vector of bytes? Let's see. Let's read byte vector. Okay, so. And I'll have to remember how to get the first out of this, but I think it's like this. And that's optional. We'll go ahead and unwrap that. We'll do let first byte. Okay, and then we're going to just go ahead and print. Hamstrung by my new keyboard, but that is fine. This will be an interesting thing. I want to print it out probably as hexadecimal, so that is something that I will need to look at the docs for. Turn on Google Chrome. We're going to take a look at print. String. All right, so let me just do my old Google foo. Rust format reference. It's probably here. Okay, cool. We'll do uppercase hex. So in that case, that'll be a capital X somewhere for upper hex. Okay. Go back. First byte is clearly I have not remembered how to do this. Let me take a look real quick. Okay. Try it this way first, and it might tell us something about it. What doesn't it like here? Unexpected token. Oh, it doesn't like that I don't have a semicolon, which may have been messing everything up in the first place. Let's see what it prints. $162. That is not hex. Let's see if we can get it to be hex. Is it capital X? Maybe that was just a syntax error for before. Cannot find capital X in the scope. Is it this? All right, first byte is A2. We finally have it. Our first byte in our streaming 33 minutes. The first byte in our binary is hexadecimal value A2, which we saw was like 160 something. I can't do that kind of math in my head. If you can, more power to you. So we are going to look at this 6502 thing. Actually, why don't we make sure that this doesn't block the main code while it's up? Pull it over here. It'll block the non-existent chat and me. All right. There we go. All right. So as we scroll down, we can take a look at the hex values for each of these, and we'll look for not that. A2. All right. A2. So there's a couple of registers here. The 6502 is really simple. It was a register machine, but it only had a couple that were super useful. This is going to be off the top of my head, and it's been a few years, but the main working registers are X and Y. In fact, there's some really good, there's some operations that we'll see later that do swaps on that kind of stuff without you having to to move something into your temperature or temporary register and then doing other stuff. The accumulator register has some particular operations to it. It's like I said, it's been a number of years. We'll see all this stuff as we go. Um, but basically, what you can see the is that there are actually a number of hex representations of load X, and they all sort of mean different things, and they have different lengths. In fact, instruction lengths. So this will be an interesting challenge. We'll have to decide um, all this stuff on the fly. You can see the timing is out to the side here, but this is an immediate load register, if I'm remembering correctly. I'm trying to remember. This is loading an immediate value into the register X to do some operation on it. You can the 0 page is not an immediate value. You can see the difference in syntax here. The immediate value has the hashtag. Um, the 0 page with a y offset, and the absolutes are offset by sorry are accessing memory, and memory is paged. The 6502 chip, and I'm not an expert, so if I say anything wrong here, I'm sure somebody will correct me. Um, the 6502 chip uh, is an 8-bit chip, so it operates on 8-bit numbers, but it has a 16-bit address bus, which is why you see that there are in absolute addressing there are 16 bytes here, or 16 bits here, or 2 bytes, whereas in the 0 page instructions, that's sort of relative to your own current page. So that wasn't a great explanation, but we'll see all of this as we go ahead. Um, so that's pretty simple to model. Why don't we do it this way? I'm gonna kind of do everything in line and extract it as I go, but like we'll do a um, sort of do it one piece at a time. I'm gonna do a loop. Loop. And I'm going to just keep looping until I run out of instructions. In this loop, um, I'm going to match on bytes. Probably need the iter of bytes here. Yeah, let's I don't need to modify each value, so I think I can just use iter. And then dot next. I'll have to remember if is there a syntax in Rust? Whoops. Where I can do like we'll figure it out. So I'm gonna match the next one. And for my default case, I'm going to panic unreachable unknown instruction. And actually, And then we're gonna go ahead and print out this instruction like we did down there as hex. And we'll need to do a format on all this, otherwise I won't know what to do. And then instruction. I probably spelled instruction wrong, so I'll fix that up. Spelled it wrong twice, which is good. Deleted the whole line. Vim, just Vim stuff. Oop. Okay. Instruction. Yeah, so that is the unreachable case, so we don't need the print line afterwards. And what doesn't it like about format here? Is it FMT? Well, I'm going to go over to Google Chrome, which I left open. Okay. Remembering my format. Yeah, that should work. What doesn't it like about that? Format argument must be a string literal. Let's see if it gives me more information than that. My does it want something here? Nope, I've really messed something up. I must have done something wrong. Let's see, what doesn't it like? I'm going to test out and see what I'm doing wrong if it's just on a different line. So let's see, format. Turn off Google Chrome there. All right, format. Hello. World. So it doesn't mind that. It doesn't like that I put it inside of an unreachable. Maybe unreachable doesn't do what I want it to do. Maybe I can just panic. Panic. I think it's not a... thought it was a macro. Okay, so now it wants a string literal for this, but if I do X... up against something strange. Let's see. Bytes. First. Next. Well, that's one thing, is the next byte is a... For right now, we're just going to unwrap it. So now it's saying it must be a string literal. All right, well, I'm going to go look at that later, but for now, I'm going to just really ruin everything. Let's see. And it's not declared as mutable yet. Needs to be a mutable iter. Bytes.next. Borrow used later here. This is this. And this is testing my memory of how to work with vectors and iterators in Rust. Let's see. So I'm going to try... Next. What doesn't it like here? It's already an iter. Right. So it definitely won't like something about this, but it's all does not need to be mutable. Yeah, it's saying this could be written as a let statement. That's because we haven't done anything with it. Now the question is, will this? I'm switching it to an iter here. Yeah, let's just try it. So the first thing I'm going to do is match on A2. And then I'm going to say that needs to be a hexadecimal value. So x A2. And then we're going to say, if we do that, we're going to do something here. We're going to print line. Got A2. What doesn't it like about this? Okay, mismatch type. Right. Unwrap it for now. That's weird. It's saying I have found type integer, which is my hexadecimal value, but it thinks that it's a vec u8, which I thought that I was maybe I need to into. Still thinks I have a vec. Let's do this a little bit different. So like if let sum byte equals bytes dot next. So it needs to be outdented. Okay. All right. So I'm gonna do this in a loop, and if it is if I get a byte out, I'm gonna match on it. Print line got a 2. Unknown instruction. Okay, so we're going to keep doing that. Otherwise, I'm going to panic. End of program. Does fs read not get me what I want to? Gets me a result with a vec of u8. Okay, the entire content of the file. Right. Oh, right. Some byte. I'm gonna match byte. I got way out of. And hopefully we're getting back on track. Let's take a look at what read does, because I clearly do not properly remember. Right. That was a silly mistake. All right, so that was an option coming in. I need to unwrap it. That's what it's saying. I'm dropping while borrowed. So what? I don't need to do that. bytes on next. Okay. For struct, that's a vect UA2. So iter. So I actually want an iter mute. Doesn't like that I'm unwrapping it and then turning it to iter mute. So it's back equals radio. Define. Okay. Unwrap this. Maybe it'll at least give me a better error this time. Hey, we did it. That's interesting. I didn't know you could not chain unwraps like that. This does not need to be mute, I don't think. Yes, it does, in fact. Okay. So once that, basically I was saying that that value didn't live long enough to get an iter mute out of it. It's probably a nicer way to do this, but we will move on from there. All right, we're back ready to run our program again. What is it saying? It's saying I don't know what to do with instruction. Okay, well, we can work with that later. So we're going to take another stab at that. All right. All right, we got A2, and then we got end of program, which is absolutely not what I expected, right? I expected each time we go over the loop to pull out a new value out of the bytes array. Let's see. I should expect an unknown instruction. So let's do a little bit of debugging. Do our print line. Byte 1. That's our bytes. Dot next. Byte 2. That's going to be our bytes dot next. And then let's see what happens. All right. We need to unwrap those. All right, so we got unknown instruction, which is what we expected. We got byte A2 and then byte 0, which is exactly right. We're if you look at the program, we're loading 0. I need to turn this off. We're loading 0 into the X register. Basically, we're going to the first thing that the program does is set a bunch of registers to 0. And okay, so this works. Can I? I'm just going to test something since I know this works like this. Format. And then let stir. Let stir equals. So it didn't care about format here, but it cares about it inside of a panic. So I'm guessing that somehow the macros are interacting. So I should be able to say let hex equal format instruction. I'll say actually I'll say message change around message format panic must have a string literal. Oh, so I can't. Oh, that's what it's saying. Okay. Format argument must have a string literal. Does panic take a format argument? Does it? Let's see. Can I say? So we know format works here. Can we say panic? That actually works. Okay, good. So can we say unreachable? So then if we run this, entered unreachable code with that. I actually like the panic better, so let's switch it back over to panic. Unknown instruction something about my string. Oh, it doesn't. Okay, that was just a question I had. So it's saying unknown instruction A9. So that is all working properly, I believe. So let's see what's happening here. Got A2, shell returned 101. So it's happening in the loop. Oh, yeah, okay, so yeah, why don't we do this? That's why I was having problems with. So we'll go ahead and expect end of program. I'll dent that. Format will save us. It doesn't know what bytes is, so it's let byte equal. All right, so then we should be able to run that, and we got A2, and it said I don't know what 0 is. So that is exactly what we were going for. Let's go ahead and commit that. commit. Read instruction A2. Go ahead and push that. No, we won't. I'll do it locally. I need to fix that. All right. So what's the next thing to do? The next thing to do, and I've been streaming for an hour and 6 minutes, which means I am running out of time and I got almost nothing done, is that we'll need to model what happens when A2 is called as an instruction. So we can take a look at what it does here on this Google page. This one, right? We found this earlier. A2, that's an immediate load from an immediate value, or that's a load from an immediate value. That's what this mode immediate means. The hex for that is A2. The length of the instruction is 2, so 1 byte for the instruction itself, A2, and then 1 byte for the immediate value, which is, in this case, it'll be 0. Takes 2. I don't think we're going to handle the timing quite yet. We will just run them in. Yeah, we'll just run them and take note of the timing later. The timing is very, very important down the line, especially when you start to draw something to the screen. But for now, we can just have some sort of engine ready to start updating state when things are called. So for right now, we just need an X register. So let's do this. We'll do a... Do we need a... Yeah, we'll do a struct. Let's see if there's something. Let's see if we have a good thing to call it. Because it's just 6502 NMOS 6502. Let's call it that so Rush won't complain about something. NMOS 6502, since I can't have a struct that starts with a number. Unless I am insane, but I'm pretty sure that I am insane. Yeah, that's syntax error. It's NMOS 6502. The thought here is eventually we might actually pull out. There's a bunch of machines that had an NMOS 6502 or a variant, and there's a potential that you could emulate the chip without and swap out the hardware behind it. Like I said, the NMOS or the 6502 and the TIA, which is the television adapter, were very tightly coupled, but coupled by instructions that I think all 6502s had. The Atari was like a cheap version of that chip, and so it's missing a couple of the main instructions. So, oops. Okay, so what I'm going to do here is try and get my keyboard to work. That's all right. We're just going to implement things as we need them. I know we're going to need a ton of stuff going down the line, but for right now, we just need the X register. That was a U8, so that's easy enough. All right. And let's go ahead and derive, debug, default. I don't know if we'll need copy or clone or anything. We'll save that for down the line. That's just an old message. What isn't it like? I probably did this wrong. Oh, I did this wrong. Okay. All right, so we have an X register. Let's do an Actually, we'll do the impl later. We'll extract things as we go and write everything in line for now. So when we get an A2, we're going to change the state of our 6502. So if we do let mute chip equal nmos 6502, we'll give a default of that. That may change down the line. And then we're going to do exactly what it says in the screen that's up on your or the page that's up on your screen, where we are going to, let's actually just copy some of that over. Let's see. We can make this a little nicer. We don't really need to. Well, we'll care about it. So we'll just do mode. Syntax. Hex, which we have here, but that's fine. This is width. And this is timing. Okay. All right. So when we hit A2, we're going to, because it has a width of 2, we're going to let arg equal bytes dot next. We'll do an expect here, and we'll say set arg for got end of file. All right, so that will pull the next one off, and then we're just going to basically update our chip dot x equals arg. And that should all line up. Found a... What doesn't it like? Expected a U8, but found a reference to immutable U8. That's right, because it's a reference, so I should be able to dereference it there. All right, so it says we have an unknown instruction A9. So I'm actually going to do a quick commit. Status. Handle. It's a little more than that, but we'll just go ahead and come back, and let's see. We've got that. So the next one is A9, and we're pretty sure that it's an instruction. I guess I'm just going to leave uh, this up. All right. Let's see. A9 is the load accumulator. So this is accumulator is used for loops. If you're a C programmer or something like that, you'll know this as the I variable in your for loop. So basically, we load up 0 into X, and then we start looping over a range of addresses and put 0 in them. That's going to be memory, or actually it can be sort of any device that's memory mapped. Everything's flat mapped here. So I'm gonna grab this. Our next one was A9. Actually, I can probably just copy most of this. So it's almost all the same other than the hex, right? Including timing. Yep. And so that has one argument. We'll do the same thing here. And we're gonna we have no field A. Easy peasy. And then let's see what happens. So the next instruction it got was 95. So an interesting thing we'll do is on each loop, we will go ahead and print. We'll debug print our struct and see what happens with it. This is our chip. All right, so you can see here, this is our NMOS 6502, where nothing happens. So that's kind of awesome. Oh, right. So we're actually loading. So we must be loading. Here we can mess with this by. So right now we're getting a default of 0. What if we? Can I do this? I do literal. Okay. In fact, we'll just do this. Chip.x equals 1. Chip.a equals 1. Clippy is happy with me or unhappy with me because I like initialized it and then did this. This just for debugging purposes, so Clippy can be quiet. You can see that after the first cycle, the X has been set to 0 and the A has been set to 0. Basically, the state of the Atari was not guaranteed on game startup, and it can be different based on whether the game or the console was reset or started from scratch. So it was up to the developer to actually set all this stuff to 0. So there could be literally anything in the X register or A register at the time that this happens. So the next thing we need to do is implement 95. Let's just keep doing. it's not 95, it's 95 in hex, but whatever. Um, Instruction. I need to actually. Right, we're not going to do that. I have to learn my muscle memory, so yeah, we'll turn back. Go back to our handy dandy. Probably gonna get better results if we do 95. Okay, that's 96. 95 is a store accumulator. Nothing too different here except that this is storing the value of the accumulator uh, in a space in memory. So we're going to have to deal with memory, which is an interesting, uh, which will be an interesting subject. Although I don't think too difficult. The memory size of the Atari 2600 was pretty small. I think we can just have it live on the stack without too much hassle. So let's see. Copy this. Then we come over here. We're gonna do. It's gonna be something very similar to this. Not very similar, in fact, but similar enough. And then we are going to. This is actually mode 0 page STA. STA. Sorry, just got distracted there for a second. 95. That's also. Let me pull this somewhere where it's better. So that's length 2 and timing 4, which we will get to. And in fact, this is not just 0 page, but it's 0 page with an offset. That offset is the offset of the X register, I believe. So, so instead of this, we're gonna do some gnarly. So we'll do memory. Offset chip. Let me see, what is the... it's not actually going to be that. This will be interesting. We'll have to figure that out. Got end of file. Okay. It's actually print artist was. We'll see what that argument is. See what makes sense. Alright. It was 0. I'm a little confused because it's trying to store. Okay, so it's storing whatever's in the accumulator to. Uh, there were also some flags to deal with in some of the other ones that we'll eventually have to deal with. In fact, let me find those. In fact, this is going to be for all of the LDA versions. So DA flags. This is LDX. I'm assuming it's going to be similar flags here. Watch me try and type LDX for some reason. But let's find out. LDX, yeah. I may have to remind myself of what this do. This is done. All right. I did something very wrong. I got rid of my bracket here. Okay, so the first thing we're gonna need to do is get some memory. So we're just gonna do memory. That'll be a slice on the of U8, and it is. Oh, hey Togglebit, how's it going? I it's definitely taking a little bit to get used to this and be natural, and I'm also trying to like talk to nobody, and putting down Rust for about 6 months, or actually more like a year, means that I am not as fluent as I'd like to be. But basically, yeah. So since you are my only viewer, I'll go ahead and recap what we're doing here. I'm doing a messy implementation of a 56 or 6502 emulator, chip emulator. It's going to be. Well, then that's a problem. If most people read the streams, watch the streams based on personality, I'm in trouble. Um, but yeah, I think you're right. I think you find somebody that you jive with, and you uh, stick to that. So, um, did you you didn't stream today? Is your day off? Yeah, I feel that. Uh, had a my little one up at 5 o'clock this morning, so I am uh, almost dead to the world here, but I'm gonna try and get a little bit done here. So anyway, what I'm doing is I am. Oh, you did fix it though. For now, until you like try and answer somebody else's question and then find the next bug. Um, anyway, so the situation here is that I am building an Atari 2600 emulator. I actually built a game in Atari 2600 about 7 years ago. I basically did the interview question for the company I was working at in 6502 assembly on the Atari, um, and uh, and so it's like kind of the system I know the most about, and I really enjoy building emulators and stuff like that. Um, Basically, all I'm doing is quick and dirty, like flat loop, and I am like just pulling off bytes as I go, and uh, and I've basically been waiting until I hit another unknown instruction. You can see what that looks like. One second, if I haven't messed everything up. There's a bunch of stuff here. Actually, I'm gonna start running this with color. Not that much color, but you can see that the thread panics with an unknown instruction E8, and then we've been going. Actually, I've been keeping this up because I've been working from it, but that's where the chat is and everything. I've been going from this sort of very old page with no styling, implementing each instruction as I go. I just got to the point where I have to actually deal with memory. So basically, I think that the memory, including like RAM and like instruction memory and the stack and everything, is like very small on this machine. So I think I'm going to be able to just stick it on the stack. But let's see if I can find memory here. Boy. I am hitting the wrong button. Sorry about that. May just have to do a general. It should be like all general overview. Let's see. I'm going to just do the old fashioned with program. 6507. Yeah, so it's a 6502 modified to be cheaper. So it can actually only address 8,192 bytes. Um, oh, okay. You're saying something really important to me. Um, I messaged you on Discord, but you can ignore that as I was just saying that I use a separate user when streaming. If you want to visit a Medium article or Reddit, oh, your email address will show up on the screen because, of course, they will. I am almost certainly. So I'm. I will create another user, although I'm not going to go to Reddit and stuff like that right now. There's a lot of little things I need to fix. Thank you, Togglebit. I am sure that I'm going to run into all sorts of crazy ways that I leak personal data. Um, Hopefully, obscurity will be a protection for a little while here. um, so I'm gonna do memory. It's a little. It's like a little not. I'll need to do some more semantics to memory here, because you can only actually like write to a specific range of addresses directly, and then a bunch of it's like program memory. So like there would be if you tried to write to it, it would be an exception somehow that I don't know how to deal with. But for now, we're just going to stick a slice of U8s on uh, on the stack, and it's going to be the size of 8192. I'm going to try and remember to turn this off for now so we can see the whole thing. All right. Um, and will default still work? It might yell at me. I need. Really, that won't default to zeros. Okay, it is actually. I'm getting my I'm getting a better microphone. I don't actually. If you would tell me how the microphone sounds, since I haven't heard it yet, um, I think that the biggest. I think it's not too bad, but I think the biggest problem is it's going to pick up a lot of background noise. So I'm getting one, but it's coming later. So I figured I would just jump in and stream in the meantime. Yeah, it's like not very expensive headset. Oh, okay. I'm in like a room with like a lot of like a big carpet and stuff, so hopefully that'll help. I think, uh, yeah, the quality is great considering it's like a not very expensive headphone. I spent a ton of money on like some Audio Technica, like doesn't have USB because fancy stuff, and it's great, but like this is just as good. Where'd my music go? Oh, well, let me. Well, I'll just do without music for now. I went for like the what is it called? I'm gonna do it on a different browser so it's not seen by everybody, but on.com. I went for like here's a good setup that comes with or like a decent starter with that comes with a arm and all the stuff you need. I have a habit, which I think we all do, of buying expensive toys and then never using them, or using them once and then they go away. So, or then they just sit there. It's an Audio Technica, but it's like the $100 version of it. So, um, yeah, it should be pretty good. Hobby photographer, gas. What is it? Does that stand for something particular that I don't know? That sounds like an acronym for something hilarious. Gear acquisition syndrome. Yeah, I would be really bad if I active I actively fight it. But sometimes it's hard. Uh, at one point I was doing a podcast with like five friends, and I was like, oh, I'll just buy microphones and like a expensive switch so we can do this podcast. And we did like one episode and didn't publish it, and I just had like a bunch of microphones in my hand. Uh, Too bad I got rid of all of them. Um, let's see, what was I looking for? Oh yeah, I was trying to remember. So default doesn't work for. Okay, so then I guess I'll have to implement it, or I can just... Actually, I'm not going to worry about it. I'm just going to not do this for now. And I'm just going to initialize this the gross old-fashioned way. Actually, it's not too gross. X 0, Y 0, memory 0 by 8192. That's a good question. This is yeah, that's I go back and forth between deciding. It's random A there. What isn't it like? A. I go back and forth between trying to name things that like in a way that will make sense to the person coming behind me, and trying to name things like they are in the chip. The On the chip, the X and Y are X, Y, A, and a couple other ones are registers. And they're sort of named that way. The X and Y are indexing registers. So in fact, I can show you an example of what that looks like down here. Uh, so this particular instruction, this version of STA, will index the 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 page with whatever's in X, but it's a general purpose register other than that. And uh, so it just does some operations like indexing memory and stuff like that with X, and it can do it with Y. And then there's an accumulator. That's what A is, and the accumulator is like your like the I in like a for loop in C or something like that. It's uh, there's some special operations for each of these because they didn't want to make everything. They didn't have the money. Thanks, Toggle. You see, I got the Streamlabs thing set up, so I got that going. But oh man, I'm gonna be out of time before too long. But yeah, so that's the deal. And I think maybe like um, I'm also not a huge fan of comments, but this might actually be like a X in register, which means like just a little bit more um, accumulator. Uh, cool. And so what we were working on was STA, which is sorry, something deep inside of me like is revolted at just a ton of comments and things, but like I feel like compiler development is one where, or emulator development is one where like you kind of need it. It would be weird to name it something that's not precisely what it is in the actual chip itself. So you kind of have to say like, here's some explanation. If you don't know what a 6502 instruction looks like off the top of your head. Um, okay, so what I was going to do is that this stores with the offset X into memory. Now I think for now I'll have to think about this. Um, so I won't mess with it too much. I'll just do what it says and might fix it in post. So the arg we get here is what we're going to store, I believe. Lost my train of thought. SDA. I will need to remember what store accumulator does. Oh, let me take a look. I won't put it on stream. Thanks. Yeah, all of those things. I might move everything over to my own GitHub account too, um, and remove the links. Yeah. Okay, so let's see. I think now is actually time to take a quick break for me. So turn down. I am actually just gonna go to that. Get some water. Whoa, I've got a ton more viewers. I've got like double the viewers I had earlier. Um, Let me see. Turn the webcam back on. All right. Oh, I wanted to fix my music. That's what I wanted to fix. One second. Hey, Arca.rs. Ar, Ar, how do you pronounce that? Oh yeah, Taco Bed. I've already done that. So I should be good to go. I need one more minute. It's a race. Is the stream buffering currently? Does not look like I'm dropping any frames. Um, I have like, shouldn't OBS tell me that? Maybe it's dropping frames somewhere else. Uh, let's see. Okay, let me know if it happens again. I'm on like a Wi-Fi mesh network that like has been really stable, and I don't want to run Ethernet cable like across the entire house. But I might do so. I'm not a like I don't do uh, sort of fast-paced gaming or anything, so like the lag doesn't bother me. It's just I'm hoping it's stable enough. Um, anyway, we've gotten a couple other people here. Oh yeah, maybe I should just go ahead and do that. I probably have to restart to do that. Is that right? Maybe I can do it live. Thank you for helping me get my settings all worked out and stuff like that. Streaming. Yeah, I don't think I can. If I can reset it while I'm going, I don't know how. So, I was just going to give everybody a bit of a rundown of what I was doing. I am building an Atari 2600 emulator. Right now, I'm working on implementing the instructions, sort of one by one, and and uh, basically just letting this panic down here let me know when I have an instruction that's not implemented. So if I run it, actually I wanted to run this the other way. Oh, cool. I need to exclude memory from that, but I don't need to print these out right now anyway. All right, I just added memory to the chip, and now it's like wanting to print all of the 80 8,192 bytes of memory every time I print out the struct. So you can say see it says unknown instruction E8, and basically I've been going through this super old uh, sort of document about what all the instructions do for 6502 and implementing them. We just got to the one where I actually need. Yeah, that was yeah, that was an 8K stack of memory printed out. I know there's a way to like. I don't know if there's an easy way to exclude fields from debug printing, but if anybody knows it, I won't take the time to look it up. I'll just not print it. Um, and look it up later. So we got to the point where we were storing the accumulator. I actually spoke incorrectly about this. Storing it doesn't offset the page by X. It offsets the address that is the argument. So in this case, the address is hexadecimal 44. And here I'll hide that for a second. Hexadecimal 44, and whatever's in the X register, it'll offset by that. So basically, the strategy here is at the beginning of the Atari 2600 program, you never know what state your Atari 2600 is going to be. It can change depending on whether you hit the reset button or just powered it on entirely. And so every program basically just goes through and wipes all the registers and all the sort of memory addresses to zero, which is what it's doing now. So the program so far has loaded 0 into the X register. What is Nightbot saying to you? Oh, Nightbot, don't. Sorry, I will turn that off right now. Give me a second while I turn that off. Don't talk to Togglebit that way. Maybe I will. I just took. Links is fine. Yeah, I used the Nightbot default settings. I would be happy for that link, which is on my. Cool. Anyway, I will deal with that later. Nightbot is out of the chat, so I can take a look at that. Put it on the other window. Turn it back on. I also like. I'm not sure why Nightbot was so rude to you. Let's see. I'm looking for something down here. Yep. What's the delay look like? I see I'm dropping frames now. 12 seconds, jeez. I guess I need to get wired. Okay. Um, OBS isn't showing me anything. I'm gonna keep going and figure this stuff out in the meantime. I don't have too much time left to stream, but um, I was looking at this and I was looking at uh, debug struct function. That's not what I wanted. Oh, that went somewhere weird. Oh, interesting. So if I wanted to do a manual debug, I could. Yeah, I could say which. I didn't know if they had any sort of like decorators for the field in the struct. Oh, so how do I find out what EA does? That's a good question. I know that I'm on a delay, but let me. So basically, what I've been doing is doing a search in here and looking for $E8. Or you just have them memorized, right? So then that is a register instruction increment X. So that's going to be basically after we set that bit of memory to 0, it's going to increment X and do the whole loop over again. There's also going to be a jump, which is going to be a big. I think I'm going to have to stop at the jump because I'll have to load everything into memory and do like a program counter instead of just like reading instructions one at a time off of an iterator. But let's get there. So basically I so I have the args and I can say my chip memory, and we're going to offset it by the arg plus chip X. If we want to be nicer about error messages, I can probably like do that differently. So, oh yeah, it's like, what are you doing? Okay, and we're gonna set that to chip. No, A. So let's see what's going on here. Oh, what doesn't it like? I need to do all that as usize, I believe. So let's do this. Let index equals. Was it just warning me that doesn't it dereference it itself? Chip.x as usize. Oh yeah, just okay. Vim, delete everything. Did it again. For those of you wondering why I'm struggling so much, I switched to. It might be up on the. Oh yeah, I switched to this keyboard about 2 weeks ago, and it makes my fingers feel like stupid, basically. I'm about half as fast a typer, and sometimes I'm just like on the wrong keys entirely. So all of my like Vim flow is like ruined for now, but hopefully it'll help with my REI stuff. So what didn't I like here? Oh, okay. So it does want me to dereference it. Yeah, it's like I get that it's awesome and it's already helping, but like it like like so I need to do all of this as use size, I believe. But it ruined my life, and then I'm also thinking about moving like a bunch of the frustrating. Yes. Yeah. Yeah. It's frustrating. Actually, it did hurt worse a little bit for like a week, just because I had like such. Yeah. Yeah. I'm still on QWERTY. I Primogen actually suggested using QWERTY and like um, remapping all the commonly used symbols to where the numbers are. I might try that after I get used to this one, because my right pinky is like killing me from reaching all the symbols. I had like compensated in weird ways so that I was using all my fingers to hit symbols, but they were like it was hurting me pretty badly. But let's see. Uh, so I actually think that does what we want it to. In fact, I'm going to. I don't want to print the memory. It's also going to be 0 anyway. I'm just going to assume it does what it says it does until I win your last. Okay. Like that. Like I just missed a key. All right. It is. Yeah, I saw him playing or messing around with the 360, and now I'm like, oh, I really should have just waited for that. Except I don't know. Except I'll just probably end up getting it and selling this at some point. Okay. So that does mean we're on to the next instruction, which is E8, which we can still do. That is a register instruction. So uh, yeah, these are sort of special. They like there should be an increment Y, decrement, transferring things around, all that stuff. So basically, I'm just going to throw E8 down here. I'm going to copy all this and reuse it. So this is inks. I'm also not dealing with flags yet. I'll have to implement that as soon as. Their fingers are off. But this is. I don't think the mode matters here. These are just single width instructions. It says the timing. Width is 1, timing is 2. I think that's the 2 is like the minimum. There might be a no op that's 1, but I think 2 is the minimum. So no argument to no argument to get, and then we just do this one's easy. Chip dot x. Uh, what's I gonna do? Plus equals? I think I was. X plus 1. Is Clippy telling me? Oh, okay, that does work here. It's just plus plus that doesn't work. Right. All right. So we should find our next instruction. I left this up because it was going to be quick. And that is D0. And that is a branch instruction. So I think that is almost certainly where I'm going to leave it off for today. Let me... yeah, so basically what that's going to require me to do is that's going to require me to store the program in memory in the correct place, and then have like a program counter that steps through rather than just pulling things off of the iterator. That'll be nice, but it'll take a fair chunk of work, and I have been streaming for a couple hours already, so I will do that next time. Let's see who is... Can I... Oh, nobody is live that I'm following. Can I, like... I'll have to figure out how to do that. Yeah, thanks for showing up, Arcus and Togglebit and the other few people who are sitting around. Oh no.
Everything about
I'm
it just pops. Unbelievable.
Bro, I mean, when...
that was main page. Let's see. Software and game development. Is anybody doing Rust? Oh, no one's doing Rust. Rip. Hey, Ergo. Yeah, I'm looking for somebody to raid. Let's see. This looks fun. Some open source Python programming going on. Oh man, this is the... How do I raid somebody I don't know? That's the question. I guess I gotta follow him first. Oh, okay, cool, awesome. Thank you, Togglebit. That is easy, but non-intuitive. Let's find that person again. Basher Zombie, thanks. Can I... Anthony writes code. Boy, I'll figure my way around Twitch at some point, I guess. Yeah, thanks everybody for joining my first stream. A lot of this stuff will get uh, ironed out, and I'll get more confident. And we'll do some really cool stuff coming up as we implement more of this Atari 2600.
Joe's. Welcome to the stream, Raiders. Oops, that's a cool name. Anything Joe's. Anything Joe's. Welcome. I guess we get to do the spiel again. My name is Anthony. I primarily work on open source Python. Some of the things that you might have heard of that I maintain are PyTest, Talks, Flake8, Precommit, PyFlakes, Dead Snakes, PyUpgrade, and many more. Today we are working on my text editor called Babby. Babby looks a lot like VS Code because it uses a similar theming engine, and you can actually control the themes from chat, which no one has done today, probably because you've run out of points. It allows you to change to whatever theme you want. It lets you change to a whole bunch of different themes if you want to. But yeah, anyway, that's Babby. Thank you, Raid. How was your stream today? What were you working on? Devfish, thank you for the follow. Welcome. Everything is a Google microphone. I got enough. I'm looking for a perfect theme. Give us some handouts. Oh, it's your first stream. Awesome. Congrats. What were you doing? What were you doing? First stream, and you have a first stream in a rate of 7. That's pretty good. An Atari 2600 emulator in Rust? Yo, that's crazy. That sounds real cool. How is just starting? Like, is it an established project? What's the spiel? That's a banger for stream. That's for damn sure. I'd like to mention people to come check it out. Okay, cool, nice. Base model Honda Accords is sold. All hail Rust. All hail Rust, right? Weird. I probably should have watched my own video. I have a video literally about the bug that I fixed here. That I put out like months ago. Don't tolerate cache methods, and look what I fucking did. LRU cache methods. That was the cause of my memory leak. Easy fix. Kevin says I should try Rust in my lifetime. Is that an object lifetime joke? And a Rust joke at the same time? I wrote a game 7 years ago and was looking for a good project. I know a fair amount about That's cool. Natural things too. Nice. That's awesome. My Python locked in server, which means it's time to order the rest book. I'll probably borrow a compiler from a friend. Why does streaming make your fingers look so stupid?
No.
My fingers look stupid. My hands are kind of small, but my hands are small. Lucas says it's easy to implement bugs. Oh, is GitHub still fucked? GitHub still fucked? I can't help that. GitHub is like super broken earlier. Oh, you couldn't type? I know that feel. I did a type racer for like 25 minutes yesterday because I couldn't type. I didn't raid you and install you. No, I got you. It's all good. Did fake hands like the lawyer guy and always sunny. I have not watched all of them. But yes, welcome. Oh, where are we at? 3 hours and 20 minutes. And Anything Joe's, thank you for the follow. Welcome, welcome. And thank you again for the raid. And Don Pepino. Yeah. Don Pepino. Thank you for the follow as well. Actually added LRU cache to a method at work not so long ago and removed it after watching your video before anyone noticed. Nice. You solved your memory leak before someone noticed. But yeah. I was pretty sure that that's what it was.